Good day, folks. Welcome to my YouTube channel. If you're new here, welcome. Don't forget to subscribe, like all my videos, watch my videos till the end. Don't skip the ads. Doing the right thing. Every video you watch, please like it, share with your friends and families. The returning subscribers, continue doing the right thing. Thank you for all your support. Doing the multiple choice question in 2023 November, the national paper, it's paper 2. Let's cut the chase. All right, now in 1.1 it says, which one of the following represent a saturated? Number one is the alkanes, which means when we talk about the alkanes, we talk about the single bonds, which is the alkanes, right? The saturated, which is the one with the single bonds, right? Now guys, if you look here, we're given these three, but we're given with 5 carbons and 6 carbons. So I'm gonna do the 5 carbons. 1 2 3 4 5 4 5. And then how many hydrogens? 1 2 3 4 5 6 7 8 9 10 11 12. Let's count it again. 3 5 7 9 12. So it's 12. So the 5 carbons with 8, it's not as saturated. Now let's do it for 6 carbons. If you look at these two, it's 6 carbons. 1 2 3 4 5. I'm counting wrong. 1 2 3 4 5 6. Now let's count the number of hydrogens. 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So which is the correct answer? Is not C, is D. So the correct answer is D. Now let's go to 1.2. Which one of the following is a secondary alcohol? The secondary alcohol it's when the carbon is attached to 2 carbons. The carbon with the hydroxyl is attached to 2 carbons. So this is a secondary alcohol because this carbon with the OH is attached to 2 carbons. So let's look for that. Now if you look at this one, it's carbon with the 3CH3. Do you see? It's 3CH3 and the OH. So that one is not, it's the that one is the tertiary. It's wrong. And this one, if you look at this one, it's a CH3 and CH2s, which is, this one is a primary. And this one is not even an alcohol. And then if you look at this one, we have a CH, and then that CH have a what? An OH, right? This one. And then there's a CH3, and then there's another CH2 there, which is this one. So the correct answer is D there. Now 1.3, it says, which one of the following is a hydrolysis for reaction? Hydrolysis, guys, there are 2 types of hydrolysis. It's when we produce the alcohol. We produce the alcohol. So there are 2 that produces alcohol. It's this and this. So this one doesn't produce alcohol, this one doesn't produce alcohol, so it's none of them. So if you look at this one, it's when it's a haloalkane. You add water and it produces alcohol and HBr. And the other type of hydrolysis, it's when you add the sodium bromide, which is not the sodium bromide, the what you call the strong base. So that's not a strong base. The correct options here, the correct answer is this one, and the one that is very close is this one. So but the correct one is this one. This is the hydrolysis, and this is not the hydrolysis. It was going to be a hydrolysis, this one, if it was a strong base, right? Okay, the answer there is A. Now 1.4, it says hydrochloric acid reacts with an excess zinc. So this is a limiting and this is an excess. It gives you the zinc chloride and the hydrogen gas there. Now it says different reaction conditions are shown in the diagram below, and the mass of zinc used is the same. So we have 2 test tubes here, both test tubes here. So we have test tube X and test tube Y, and the zinc that is here is a powder and the zinc here is a lump, which is the surface area of this one is smaller and the surface area is greater, and then the concentration is the same, it's 0.1, and then the volume are not the same. So if you look at these ones, due to the state of division there, this one is going to have a higher reaction rate, higher reaction rate, and this one will have a lower reaction rate due to the surface area, right? And also, if you look at the volume here, the volume here is greater. That means if you go to the formula that says C is equal to N over V, the volume, so if the volume is bigger, that means the concentration, which is the number, the concentration of this, it's going to be smaller. So this one, it will have a lower rate. Now the question it says here, how will the initial rate of reaction and the final volume of hydrogen produced in test tube Y and compared to test tube X? So the rate of, okay, the question here, we're comparing the initial rate and the volume. So this one, guys, will have a higher volume of hydrogen that is produced, this one compared to test tube Y. Why? Because of the reaction rate is higher, even the volumes are different, so it makes this one to produce a higher volume of gas. So the options here, it says in initial reaction for Y is not higher, is lower, yes, and is lower, yes, and is not higher. Let's look at the final volume. Now it says the final volume, guys, even though this one is going to have a higher rate than this one, but this one will produce more hydrogen, more volume of hydrogen. Why? Look at the volume of the HCl. It has a bigger volume compared to that one. So now when you increase the volume, the pressure decreases. So if the pressure decreases, that means it's going to favor the side with the less number of moles according to Le Chatelier's principle. If you look here, there's no gas at all here, so it's 0 number of moles. So in this side you have 1, so it's going to favor this side. So if this side is favored, that means the volume of hydrogen is going to increase for this one specifically. So the answer here is what? Is more, not equal, right? So the answer is B there. Now let's go to 1.5. 1.5, it's a chemical equilibrium. It says in the diagram below, represent a mixture of nitrogen dioxide and that N2O4, I forgot that, molecule at the equilibrium at 1 dm3 at the temperature T. Now if you look here, we're given the balance equation here. It's nitrogen dioxide, it gives us that. So these are the products, these are the reactants. So these molecules we are given, they are given the molecules there. So the nitrogen dioxide is those ones, and how many are they? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 12 of these, right? And then how many the N2O4? It's 1, 2, 3, 4, 5, 6, right? It's 6 of them, right? It's 6 of them. Now let's go to the question. It says which one of the following is true for the value of equilibrium constant, which is Kc at temperature T. So is the value going to be equal to 24, value greater than 0, value, you see? So now what we're going to do, we're going to calculate the Kc using these molecules here. So we're going to say Kc is equal to the concentration of products, which is the product, it's what? It's N2O4 to the power 1. You don't have to put the 1 there, and over the concentration of reactant, and then NO2 to the power 2. And then what do we have here? What do we have? We have the nitrogen oxide. It's nitrogen dioxide, it's 12. No, it's the product. The product is what? It's 6. 6 divided by what? Divide by 12, 12 to the power 2. So if you punch this in the calculator, you'll get a value that is less than 1. So you get a value that is less than 1. So the value is not equal to that. It's not that. It's a value that is less than 1. So the answer is going to be D there. Right? If you do the case there. Right? If you're looking as well, the concentration of product, the concentration of products, or the number of moles of products are lesser than the number of moles of what? Of reactants. If you're looking there, the products are lesser than the reactants. So that means your Kc value will be less than 1, which is it falls in that range. Now let's go to 1.6. 1.6, it says here, the reaction at equilibrium in a closed container according to the following balance equation. We have a copper oxide in a solid state. It gave us the copper oxide in a solid state as well, and an oxygen. Look at it's a heterogeneous equilibrium. This one we have a gaseous state and solid there. Now it says the volume of the container has now increased. Very important. Now while the temperature remains what? Constant. Important information. The new equilibrium is reached. Now it says here, which one of the following combination is correct for the new equilibrium? Now let's go back there. Let's go back there a bit. They say the concentration has been increased. So if the concentration has been increased, that means the pressure is going to be decreased, because their volume and the pressure, they are inversely proportional, right? Now we know when the volume has been increased and the pressure will decrease, and will favor the side with the more number of moles. So the number of moles here of gas is 0, because the state is solid, and then that one it's a 0, and then we have 1 gas. So the decrease in pressure favors the side with the more number of moles, which is what? The oxygen. So it's the forward that is going to be favored here. So the number of moles of oxygen is going to be what? Increased. So the pressure is going to be increased today, which means the number of moles is going to be increased, right? So now it says the concentration at equilibrium. Now, the concentration of oxygen, what's going to happen to the concentration of oxygen at equilibrium, guys? When it reaches the equilibrium, the concentration does not decrease. At equilibrium, the concentration, it remains what? Constant. It does not decrease. So the option lies between B and C. Now, what's going to happen to the number of moles, of oxygen? What's happening to the number of moles of oxygen? The number of moles of oxygen, is it going to decrease or is going to increase? Look there. What is happening to the number of moles of oxygen? It increases there, right? If you're looking there, it increases. So if it increases there, so this is the option. So it does not decrease. This is not an option. What's happening to the Kc value? Remember, the Kc value is influenced by the temperature. So we are told that the temperature here, it remains constant. That means it's going to be what? Constant, right? So our answer here is what? Is C. Now 1.7. 1.7, it says a nitric acid, which is that, an ethanoic acid. Remember, the nitric acid is a strong acid, and an ethanoic acid is a weak acid. Right? Of equal volumes and concentration are compared. So they have equal volume and equal concentration and are compared. So now it says, consider the following statement regarding this solution. They have these two, they have different pH values. That's correct, right? They have different pH. So the pH of this one is going to be less than 7, and since it's a strong acid, it's going to lie between 2 and 3. It's going to lie between 2 and 3, if I'm not mistaken. And this one is going to be it's gonna lie between 4 and 6 is going to be there, so they have different pH. Now statement number 2, it says both they have same electrical conductivity. It can't. So this one, it has the stronger electrical conductivity due to the pH and due to the strength. This is a weaker, this is a stronger. So high electrical conductivity, low electrical conductivity. So this one is not correct. Now it says both solutions require the same number of moles of potassium hydroxide. That's the caustic potash, and for the completion of neutralization. I think this is correct as well. How? Now if you take the nitric acid and you react with this base, which is the KOH, so you have the KNO3, that's the salt, and water there. So the equation is balanced. So the number of moles of this is going to be 1. And then if you take the ethanoic acid and you react with the same base, so the product there is going to be CH3COO K plus water. So the equation here, it's balanced as well. It's already balanced. The base is going to be what? 1. No, man. So if you look here, not this one, guys, this one. If you look at the base, the number of moles is going to be 1. It's going to be 1. So it says both solution requires the same number of moles of this one. So the number of moles that they require, both solution, this solution and this solution, is the same. So the answer here is between 1 and 3. So which one of the above statement are correct? It's 1 and 3. So the answer in 1.7 is C. I hope I make sense by that. Quickly to 1.8. The apparatus in the diagram below is used for titration of HCl and KOH. Guys, it's very important to understand the strength of acid. This KOH is a strong base and this one is a strong acid. So the strong acid, the end point of a strong acid, the concentration of hydronium ion is equal to the concentration of hydroxyl ion, which is the end point. It's what? It's 7. When you add the two, their end point is going to be 7, which is the pH. This is the pH, is going to be 7. Now let's read. So when you titrate the two, the end point is going to be 7. It's going to be, which is 7. It's what? It's neutral. It's neutral. Now it says in titration, the learner accidentally exceeded the end point. So when they exceeded the end point, that means they added more acid. So this one is going to be what? It's going to be more acid here than the base. The acid is going to be more than the base here. Now it says which one of the following statement is true? If it's more acid, if it's acidic, it's more acid than the base. That means the concentration of hydronium ion is going to be greater than the concentration of hydroxyl. So this is the correct answer, right? It's not going to be less because it's more acidic. They had this represent the acid and represent the base. More acid than the base, right? So that was another option. Second last question. It says the following hypothetical standard reduction potential relates to the galvanic cell, right? So we have these half cells. These are hypothetical, guys. Hypothetical means they do not exist. It's just there. Something that is hypothetical. It's whatever. Right now, if you look at these half reactions, guys, we're given the standard reduction. But if you're looking at the values there, the one that is positive, that means it's a what? It's a cathode. The one that is negative, that means it's a what? It's an oxidation. Or in other words, the one that is smaller, it's oxidation, which is it's an anode, right? It's an anode. The one that is smaller, the one that is bigger, it's a cathode, right? Very important. Now, and that means that this one is undergoing the what? Reduction, and this one is oxidation, right? Now it says consider the following statement for the galvanic. It says the EMF of the cell under it's 0.2 under the standard condition. That is correct. How? If you say if you're counting the E cell here, The E cell, you say cathode minus the anode, which is it's 0.1 minus 0.1. So it's going to be 0.2 volts. So this is correct. Now it says the electrode Y is an anode. So the anode is going to be here. So the electrode Y is an anode because this is an oxidation. So the electrode Y, it's an anode. Yes, this is correct. Now it says X is oxidized. That's not correct. X is there. X is there. It's not oxidized, it's reduced. So this is incorrect. So the answer is between 1 and 2. So the answer 1 and 2 is B. Now the last question, it says which one of the following half reaction below will be the main reaction at an anode during the electrolysis of the copper concentrated copper chloride. In the electrolysis of the concentrated copper chloride, it decomposes to copper 2 plus Cl Cl minus, but it's 2 of them, right? So guys, the anode, if you look even in the standard reduction potential table, this one, which is 4B, this one is gonna oxidize the chloride. It's gonna oxidize. It's gonna be 2 chloride ion oxidizes to the chlorine gas plus the 2 electrons. So the anode, it's gonna be this, and the copper, it's gonna be what? Reduced, which is going to gain electrons to copper copper. It's going to reduce to copper. So this is an oxidation and this is the reduction. So the anode is going to be this one. So it's not going to be that, it's not going to be that, it's not going to be that, it's going to be D. I hope this multiple choice, guys, it makes sense. Thank you. Cheers. Bye.